Hi, my name is Alex. I'm iOS engineer in Prolific Interactive, and today we're going to talk about design patterns, the strategy and the factory design pattern, especially what are they good for and how can they help you in unit testing. So let's imagine that we have a story. We need to create a login page or registration page for your app. Basic requirements are you need to be able to enter email and password. We must be able to validate if email is good and if password is good. Things like lengths, allowed symbols, and so on. Let's jump into the code straight up. So this is the typical controller that you probably had built multiple times. It has email field, password field, which are regular UI text fields. It has some action on the button to validate both fields. It has simple validation method, is text valid, that takes two arguments, the text itself and the type of the entry, and returns a boolean. Underneath the hood, it's using regular expression to validate the entry text field, which is stored in the enum entry type, like this. Nothing special, the typical way to validate your emails and passwords when you need it. Then, when you tap the button, we call the regular expression to validate method. It calls is text valid on both email and password fields. And then if both are valid, it does something with the screen, dismisses the screen or proceeds making an API call and so on. So this is, as you imagine, is not ideal option. We have a couple of problems here. Let's return to the presentation for this. This code has several problems. First, it's a step closer to the massive view controller. As you can see, this has only two text fields, but you can easily add multiple text fields, zip code, address, billing, shipping address, whatever, and all of them has to be validated. This is not really scalable approach. It's confusing, and it will be everything in one place. So it's unscalable and it's hard to modify eventually. So the first attempt to fix this situation would be to decompose the code into different classes. So now we have a protocol validatable. Thanks Swift for having this nice protocol. We have a default implementation of this protocol, has valid entry, which returns a boolean, and basically does the same as the code is the same as we did in the controller before that. It's just hidden in the extension. We also have two new classes, email field and password field, which are both validatable, both subclasses of UI text field. The only difference is that they have this property entry type, which is email or password. And when we validate the entry, we look at this default entry type and make a validation based on this property. So in the view controller, it will look like this. Instead of passing a couple of arguments to the validation method, we just ask email field has valid entry and password field the same, has valid entry or not. So it's much simpler, much cleaner. We have more files, which is a downside, but it's much more readable even in this simple example. But it still have problems. What if we need a different type of validation? For example, if we need a postal code, not just a zip code that have 5 digits, but postal code that can be different values in different countries. What if you need some special validation for address or credit card or whatever? This one this has valid entry method quickly becomes unscalable, completely unscalable, even if we add different regular expression validators to the enum. Also, it's hard to maintain still if we need to add different text fields. We need to modify we need to add another default implementation. We need to add we need to modify enum with the entry type, and basically there is a lot of logic still in this code that has to be tested, which is also a bad thing. So now we're talking about the right way to make this code better, which will be applying the strategy pattern. Once again, we scaled the solution that we had on the previous slides. We still have the protocol. Now it's called validatable strategy. It still has the entry type property, but now it also has a validator. So default implementation of validatable strategy now, instead of having some code, we'll just call the entry validator, the validator, which is an object that knows how to validate the specific type of an entry. In this case, it's a struct. It's a regex validator. So every type of text field that you can validate with a simple or not so simple regular expression can use the regex validator. If you will need to add different text fields with other rules, you create another struct or class, for example, postal field validator, which will conform to the same protocol but will implement the method in a different way. And we also modify a little bit our classes. This, for example, is a postal field class. It still has the entry type, but it now has the validator, which will be used by default to validate its entry. You can see that we have more code now, but it's actually not a bad thing about the strategy pattern, but a benefit. You have actually more lines of code, but less logic. And if you have less logic, you don't need you will need to write less tests. Look at the postal field, for example. It has static variables, basically constants that are defined once and forever. You don't need to choose anything. It doesn't depend on anything. You just create a postal code and that's it. The only logic you have here is the enum type that you used for regex validator. The specific regular expression that is used to validate the regex validator. And here, for example, in the postal text field, we have the postal code validator, which uses different type of validation that is not on a screen, but you can trust me on this. I don't know. The important thing about the strategy pattern, a little pitfall that you can use while implementing it, is to create a validator based on some kind of logic, based on entry type. Like here, based on the entry type, the email or password has the regex validator, and the postal code has postal code validator. This is an easy step to make while you implement the strategy pattern, but this is the thing that strategy tries to avoid. More logic. So the less logic you have while you're implementing it, the better your implementation is in this case. So this was the strategy pattern. We cannot talk about patterns without the quote from Gang of Four. So this means strategy pattern means defining a family of algorithms, encapsulating each one, and make them interchangeable. Strategy lets the algorithm vary independently from clients that use it. three key words in this expression is encapsulating. Everything is in its own class, interchangeable. You can use any class, any type of validator. You don't care. The client of the class doesn't care what type are you dealing with. It just has the right type of the validator as a property. And independent, of course, comes with encapsulation. If it's easier for you to get at the scheme, to get the information from the scheme, we have the calling component, which in our case will be the view controller, the context class, the text field, whether it's email text field or password or whatever. And strategy protocol in our case is just encapsulated in the protocol extension validatable strategy, which chooses the strategy implementation and just pass everything back to the calling component. So the only logic we have here is in the strategy protocol. That's it. The good things about the implementing a strategy pattern instead of the default implementation is it's definitely much more scalable. It has a logic encapsulation. It avoids the code duplication. It's easy to test, and it's getting easy to find and fix bugs. If you can imagine, if you have a class that has only 5 lines, of course it's easier to find anything there, and it's difficult to put something in there that would cause some bugs. Downside, it's arguably a downside, but there is a lot of files. Even if in our example, if we can look at the code right now, for just a login component, it has enum, validatable protocol, entry validator, regular expression validator, a lot of files. And it's just the beginning. It's just something that we just started. We didn't scale it yet. It can easily be 20 files just for this feature. So maybe this is a negative part, maybe not. I don't know. One major thing that I want to say about using the strategy pattern and the factory pattern later is that if you want to test your code, this leads to the less code that you have to test. As in, you don't have logic anymore in your classes, in your implementation. You don't have switch statements, you don't have if statements, no conditions. So since everything is right in front of you, everything is set as a constant, you don't really need to test it. You just need to test the basic logic that is situated in one class, that is placed in one class, and that's it. So you have 20 files, but the test, you need to test only one. Instead of by default implementation, as I showed in the beginning, you would need to write probably 10 tests just to make sure the logic is right for every text field. The second pattern I was going to talk about is a factory method pattern. And this way we'll start from definition and then go into the code, because it's starts from much more hairy code. So strategy method pattern is defining the interface for creating an object, but let the subclasses decide which class to instantiate. Factory method lets a class defer instantiation to the subclass. So what it basically means is it's kind of a strategy pattern, but for creation of the objects. For the example, so we have a controller here. This is used basically for in a library app to check out the book, but it has a lot of alerts in itself. For example, the success alert, success message, or the error message, or whatever, some actions that you need to do. As you can see, it's about 60 lines of code of just methods that are calling, that are creating default alert controllers, creating actions, and trying to make sense out of it. It has logic in it. In everyone, the message depends on the argument. The string, the option of the string depends on the argument. The alert title is different every time. It has a lot of logic in it. The message depends on the success boolean. If there was success, there is one string and another. If it's a failure, alert title has different options based on the success. It's for the controller. Also, the alerts have the same problems. It has different titles. You may imagine that here it's not, but it can have different actions based on success or failure, and so on. This is only for one alert. I will not argue that this code can be written better, but imagine that if it were perfect, you wouldn't need to implement any strategy. You would just leave it as it is. But for us, this is a good option to illustrate how can you create a factory method. So as I said, this has about 4 or 5 different types of alerts. Let's try to encapsulate it in some way using the strategy pattern, the factory pattern. Sorry. So what we have here is the new alert type. For now, it's just 2, success or failure. And we have a struct alert factory, which based on the type, basically based on alert type right here, it creates the ready to go alert configurations. It's called alert configuration because we cannot subclass a default alert controller. Apple doesn't allow this. So here we have the struct alert factory that, based on the alert type, creates an object which is a settings for success or failure alert configurations. These objects are configuration, not the actual alert controllers, because Apple does not allow you to subclass basic UI alert controller. So the configuration contains only the properties that title, message, preferred style, actions that you use later to create the controller itself. So we create the settings here based on the type, this one, and then we create alert controller just passing the settings that are predefined and add actions. So this is a simple simple factory, simple code. What are the benefits of it? Let's take a look at the configurations. Here we have the protocol, which is basically on every screen right now, so it's not the point. The point is we have, for example, 3 here, different alert configurations with also predefined types. If it's a success alert configuration, it will have only one title. It's a constant success. It will have only one message. It will have only one preferred style, and it will have a bunch of alert actions, which may be created in our case either here or using another factory if you have more complicated actions. These are all in one file, but you can imagine that, again, this factory pattern, as the strategy one, makes your files much more countable. So again, all the actions here are predefined. All the logic that we had in the controller before that depends on the success message or whatever the conditions are eliminated here. We don't need to test what are the properties of the action anymore, because they are not variables. And in the factory, the only logic that we have is the switch statement in the heart of the factory, which is settings for alert type, and we cannot avoid it in any case. So this is something that we have to deal with. In strategy pattern, we didn't have even this type of logic. It was pure static, pure constants. I don't really have the implementation of how it will look after, but I didn't erase all the code that was old, but this is the new kind of action that is created by the new factory. It defines the action, which you can once again use the separate factory to create. And it uses the alert factory to create alert controller of type. And it just passes actions. So instead of creating a controller, creating an action, defining the properties, everything like this, you just pass a type. And that's it. Everything else is done for you. Once again, let's return to the presentation. Let's go over the problems that we have. If you have multiple classes that do similar things in a different way, they conform to same protocol or subclasses. If you need to select one of those depending on a scenario, once again, we have either success or failure on the action. You need to use those classes in multiple features. Once again, the alert controller is something that you use all over the app.
Let's hold on. Okay. This is from the book.
We cannot use this. So the benefits of applying the factory is kind of the same as from strategy. Actually, it's almost the same slide. It's scalable. It has logic encapsulation in only one place. No code duplication, easy to test, easy to find and fix bugs. And again, the possible downside is that there is a lot of files. And it's not the downside, but this is something that you have to get used to. You're used to use variables and leverage the if statements and switch statements, and factory and strategy patterns both teaches you that this is a bad thing, that you need to use constant as much as possible. And if you new to object-oriented programming, this is kind of a weird concept, but I just wanted to make this statement here. You probably use this kind of code lots of times when you need to create a controller. You instantiate the storyboard with some kind of name. It doesn't have to be a literal string. Of course, it will be a constant. You need to instantiate a view controller with some kind of identifier. Again, this shouldn't be a literal string. It can be a name of the class. Then you need to cast it to either it's the class you want or not, and only then you return it. What the controller factory allows you to do is to just leverage in generics, specify the type of controller you want, and just create the controller, encapsulating all the code in one place. So how the controller factory looks like. Again, the logic is encapsulated in only one method. In our case, it's a storyboard ID, which every time you create a controller or you use a controller in this class, you need to specify a type and the storyboard that this controller belongs to. And then you create a storyboard for type with the defined ID and instantiate the controller leveraging Swift generics. That's it. You can go even further and eliminate the optional value here with throwing a fatal error if you in the guard statement if the controller cannot be instantiated from the storyboard. And in the end, you'll have a clean. It can be one-liner, not even the 4 lines of code, but just a simple and cozy way to create your controllers. Once again, just for more clear view, no widescreen, we had a little hairy way, and also this is a bad thing because you instantiate it all over the app, and if you at some point you want to change the method that you instantiate the controllers, create an extension for storyboard or something like that, or you change the strategy of defining the identifiers for controllers, you need to go over all the app and change it, while with the controller factory everything is in one place, which is a good thing. The sources for this presentation, first of all, the Pro Design Patterns in Swift. It's a nice book in terms of it has Swift examples, others don't. But it's kind of the same with the Pro Objective-C design patterns, but they have different examples which can allow you to understand it in a better way. The great book for learning design patterns is Head First Design Patterns. It's a little goofy language is used there, but it has the best explanation, for example, for the strategy pattern that I have met in all the sources. I probably shouldn't mention, but this is John Lean, one of our engineers, which is a super expert in every. You can probably just ask him if you need to implement some kind of the pattern. So that's it. Thank you.